Well, hello again. We're going to come back and show you what just happened. We remember working on our Raspberry. Between the two of us, we'll go ahead and explain what's happening. So I'm going to share with you the screen here that we've got.
I'll just pilot it.
Okay, you'll just pilot and hold on a second. Let me make sure we're on the right screen so we can see what you got. All right, Daryl, tell us.
Is there no snapping to grid? No, doesn't matter. Okay, so the issue we had previously. So the computer interpreted the 0 as a no, which also means take picture for some reason because it's a signal, although it means don't take a picture. In other words, for a computer, it still took the picture, although it's an empty picture with 0 megabytes in size. So what we want to do is that we want to omit the intermediate messages such as 0 and any other following messages. So we added a short delay that limits only one message every 3 seconds. It's a very simple layout.
It's been cutting out. Hold on.
Ooh,
Can you?
Dang.
Yeah, it's been cutting out. So if you could repeat what you just said.
Cool. All right. So the way computers work is simple. It's binary, zeros and ones. The issue with the button is that it was sending both a yes and a no, or a 1 and a 0. And the 0 message is interpreted by the camera node as like, hey, take a picture. But since it's a 0 node, it also means no, don't take a picture. So that limits one message for 3 seconds. That's good.
Can you double click on that? Let's just look and see. Oh, notice, what's that drop intermediate messages thing?
So basically, after the first message, any intermediate or following messages would be dropped or ignored.
Okay.
Based on the rules we have set here, we only limit one message, which is always going to be a 1 or a yes for the button. On top of that, we added a delay for 3 seconds, so that means that you could only press a button once every 3 seconds to take a picture. That can be adjustable, but 3 seconds is roughly like a good padding time. And yeah, basically what this node does is that it would take the first message, which is always a yes or a 1, and it only takes that. And any other following messages would be dropped until the 3-second timer is expired.
All right, well, let's try it. Here, I'll go ahead and switch over to our screen where we've got it. I'm going to go ahead and push our button, and if I push the button, camera comes on, and boom! Oh my gosh! How'd that happen? There's something like that looks like the ceiling of Chester's shop here, but what's cool is that it just showed up as a preview on the screen. Maybe we can unpack what happened there a little bit.
Alright, so previously we had to navigate to our file explorer to, well, view the file. Well, with the combination of executables and command lines, it's super easy to get this thing running. So basically, we have a special node here. It's an execution node. I almost called it an executive node, like it's important or something, but I digress.
Where would that node be found? Where do you think it would be? One of these ones over here.
I'm gonna guess function.
There it is, advanced.
All right, we're not ready for the advanced portion yet.
Well, let's just, it's over there. So if you double click on it, we can figure out how it got set up. There it is. That one runs a system command and returns its output. So let's double click the open image file and tell people how they would get that, how they should set theirs up.
So basically, if you're familiar with Linux operating systems, they use Linux commands or bash scripting and things like that. Everything in the terminal can run a command. And this is a command that can be run in the terminal. And what it does is that it would take whatever the input is, which in this case the picture, and it runs this command. So if you were to copy and paste this into something like terminal, it would take that and execute it.
Cool.
And the way it opens the file is that it takes the message payload, right? And yeah, it's just how Linux works, really.
So if you want to set one of these up yourself, you can go and type that stuff into your executable file, and as long as you type it in just so, it'll come out. There's also a tutorial that's on our website, and I'll link to that down below in the comments.
I'm actually curious on what the message payload looks like for the camera for a second, what kind of data does, or what kind of file or string does it attach to the command? So I'm actually gonna
Deploy,
actually
delete, clear that, and I'll push the button.
Let me delete this guy.
Okay. You only want one debug node to be on your thing at one time.
Yeah, I don't care about the button.
Okay, so here we go. Pushing
that.
the button, and yes, the camera should have taken a photo.
Right,
Oops,
so
I was wiggling my hand.
So the message that it sends is the file location.
Ah,
So
pretty cool.
if we were to do this completely in the terminal, so I'm going to take the command here and open up our own terminal. Oops, now we're getting scared about black boxes. Oh, shucks. It's, I think it's... Well, it's Command Shift V. There it is. And on top of that command, we copy our file directory here. I think we also need the quotation points. Yeah, we do. No, I don't think so, but it's better to be sure. And boom.
Hey, look at that. Wow. Okay, so we just learned two big things. One is how to set up your camera, and then the next is how to set up a little executable file that shows you a nice display of what your photo should look like. But if your students are wondering where's that photo being stored, it's somewhere on your Pi, and
they call it advanced for a reason.
Yep.
It allows you to run commands with, yeah, it's pretty cool.
Yep. So with this one little tool here, we could set this up and leave it for a while. It could come up with all sorts of options and things like that. What usually after a student plays around with setting up a camera and doing the basics like this, I like to introduce them to some of the other options besides just a button. And one of the other options that is typically shared is what's known as the PIR, or the motion sensor. So I'm just going to run through a few of these things here. Again, you'll have a link to this on here. Play with your settings. Give your students time to play with the settings, mess around with the camera. Hopefully they don't get that same issue that we just got, but if they do, then hey, you can pack through it. Just remember that a button is a 1 or a 0. That's how it goes when you push it. But there are other kinds of data out there. This is known as digital data. There's other kinds of data which are known as analog data, where it doesn't have such a clean 0 and 1. So oftentimes what we'll use to mess around with, instead of a button, let's try it with an infrared sensor. And an infrared sensor essentially takes light that comes from, well, I'll go into how this thing works in just a minute, but know that it's like a motion sensing thing essentially. So it's got the same 3 pins on it like we had on the button, the VCC, the 5 volt, the output pin, and the ground pin. So if we hooked them up to the Pi in the exact same fashion that they were, they should work. And it gives us, you know, the basics of making a selfie station. And I think I've already shared this video clip with you guys before in the past of the students describing how a selfie station is created. If I haven't, I'll put a link on this tutorial down here below. But I wanted to show you, if you have a situation where you have a variable sensor that comes in there, something that's like a sonic sensor or a temperature and humidity sensor, light intensity, when the values reach a certain level, then they trigger an output. And that's kind of different than the button. Does that make sense? The button is on or off. There's 2 states. But in the real world, if we're talking about how warm it is in here, or if we're talking about how close an object is or something like that, then it's a, if it hits this state, then I trigger something to happen. So, you know, our next activity is going to be setting up a sonic sensor where we'll plug it in and we'll make it turn on and adjust things as it goes. And there's all the stuff for it, for how do you set those things up, and then students can play around with that. And I'll put together those links to those tutorials in there. I think we're going to go ahead and let you look along those tutorials for that today, and that's it for today. So thank you guys very much for joining us today, and yeah, we'll see you next week with some more lessons on T3 Alliance lessons. All right, thanks everybody. Have a great day.